Uh, so today we are going to talk about linked list, and also I'm going to solve two problems from LeetCode, reversing a linked list, and this is the easy problem on LeetCode, and this is a medium question on LeetCode. Linked list cycle 2, and I remember, if you guys remember, if you have been following my channel, we did linked list cycle 1 problem, which was an easy problem from a LeetCode, and both these problems have been asked at the big four companies, so I'm really excited. So let's see what a linked list is. This is from Wikipedia. So linked list is a linear collection of data. So it has two things. It has a data and a reference to the next node. A node is nothing but it consists of a data and a pointer pointing towards the next node. I don't want to spend a lot of time talking about linked list and what it is. You can always look it up on Wikipedia. So before we solve those problems, I want to do two things. So we'll do a simple, we'll insert at the beginning of the linked list, insert at the end. We'll try to traverse through linked list, and after that we're going to solve two problems. So first thing what we do is create a class node. I'm coding along with you, and this is in Python, and I'm using this is a pretty good tool, to have an online editor. So we'll create a constructor, and our constructor will have two things, right? Data, and where we'll set data equal data, and we'll have a next, which is the pointer pointing towards the next node. So for now we'll put it in none. Okay, so now we are going to create a linked list class, and we'll say object. Okay, and we'll create a constructor. So I'll encourage everyone to read on Wikipedia what linked list is. So we'll have to self.head equal none and self.tail. We just have to initialize it. So let's do a insert at front. We create a method calling insert at front, and we'll pass along the data. So let's do a new node, which will consist of the data. So we have to think about two things, right? If there's no elements in the list, we have to insert it at the beginning. If the head is none, we have to insert it at the beginning. And if it's not, so let's do first case. So if not head, this means there's nothing in the list. We just gonna do, point self.head equals self.every, like the tail, towards the, can't spell, tail towards the new node. Else, so we know we have a list. So what we have to do is, head is pointing towards, think about there's an element, let's just say we have 1, pointing to a 2, pointing to a 3, and, right now the head is pointing towards 1, right? So what you have to do is, we created a new node, and we have to point that next node towards 1, which the head is pointing towards, and we have to reset the head points towards the new element. So it's pretty easy, we have to say new node dot next should point towards where the head is pointing, right? So think about, there's a new node which has a data like say 5. So when 5 comes along, so we have to, head is pointing towards 1 right now, right? So we have to point the new node next to 1, right? And then move head towards the new node. So now we have to move head towards new node, right? And okay, so we have to point towards self.head. Okay, this is done. It's pretty simple. Let's do another one. Let's do how do we traverse through, through a list. Hope you. So let's do create a method, traverse, and let's do stuff. We'll have a pointer which will be current, like pointing towards the head. Okay. So what we'll say, like when this data and current.next is not equal null, what's the problem? Indent. Okay. And then there will be a problem again. So we have to indent it right. And Python is really, about that. So let's do that. Okay. So what we do is like print, we'll traverse through it and we'll print the current.data. And we'll move the current pointer to the next one. Let's test it out first. Okay. Let's create list 1 and let's say linked list. So let's insert some data. List 1. Let's insert at front. Let's do 1. I'm just gonna copy paste. Okay. Let's say 1, 2, 3, and 4. And we need to print it as well. So we'll say print. Traverse. Okay, let's try it out. It should print 4, 3, 2, 1. That's what we got, right? So I'm gonna also teach you how to insert at the end. Let's do it right here. Insert at end. So let's write the method first. Insert at and we'll have self and data. So we'll also create a new node, which is the node and the data. Okay. So again, it will have, if there's no element in the list, if not head, I can spell self.head. I'm trying to type fast. I'm not good at it. Okay. Head. Okay. So then we'll say self.head equals self.tail and equal new node. Else. So let's stop for a second. So we have right now we have let's say 4 pointing towards 3 pointing towards 2 pointing towards 1, right? So right now the tail is pointing towards 1. If there's no element, so we'll just insert at the beginning. Right, it doesn't matter, but let's consider the second use case, right, else statement. So right now the tail is pointing towards the 1, right? So what we have to do is point, this node next pointer towards the new node, whatever the element we are inserting, and then move tail towards the new one. So we are going to insert 5, let's say. Okay. So where's that? Okay. So we have to do wherever the self dot tail dot next node should point towards the new node, right? And now the self dot tail should be a new node, right? So what we did was self dot tail is pointing towards 1, and its next node points towards 5 now, and we move tail, which is pointing towards 5. So let's try it out. Like let's insert 5. Where is it? 46. Oh, traverse. Okay, traverse. What we said? No. Okay. What's the problem? Okay, no, not this one. Okay, my bad. So we have to do list 1 dot insert at end. Okay. Let's do that. Okay. Oh, it removed it. 4, 3, 2, 1. Insert an end. Let's go back. Okay, new node. Okay, self dot tail dot next node equal new node and self dot new node. Oh, look, it said self dot tail should be next, right? That's why I don't really like autocorrect. Auto completion. Sorry, not autocorrect. See, it inserted 5. So this is pretty simple. I'll share the link with you guys, and let's do a, let's call it link list. Let's say Python and save, and I'm gonna share this with you guys. So share. Okay. So now let's go back to reversing linked list. This is a easy question on LeetCode, and it's been asked at Amazon and the other companies. So what does it mean? So let's say 1, 2, 3, 4, and this is pointing towards null. So you have to return, what you have to do is like 4 pointing towards 3, 3 pointing towards 2, 2 pointing toward 1, and 1 will point towards null, and this 4 will be pointing towards head. So we have been given a linked list which has self and head. So it's pretty simple. So what do you have to do? So I'm thinking of solving this problem because rather than the current node pointing towards the next node, it has to point toward the previous node, right? So it has to point towards 4 has to point towards 3, 3 has to point towards 2, 2 has to point toward 1, and 1 has to point toward null. So we'll create a previous which will be equal none, right? And current will point, let's say current points towards head. And I think I have to comment this out. Okay. So while current, so we'll create a temp because we have to keep a reference. We don't want to lose a reference of the next node. So it has next. Okay. So current.next, rather than pointing towards the next node, it'll point towards the previous one. So what we'll do, current.next equal previous, and then we have to move previous as well, and the current, we have to move so 1 point towards previous, none, current pointing towards 1, now current is pointing towards, and we just have to traverse through it. And so we'll do previous will now point towards current, and current will will point towards temp now, and we just have to return previous, right? Ooh, return previous. Let's try it. Run code. Okay, so let's create a list. 1, 2, 3, 4. Oh, done. Submit the code. Pretty simple. Okay. So this is a cycle. So, we have to think about. So I thought, I got a really good explanation towards this one. Let's see. Program interview. Not this one, but this is also a really good platform if you want to learn how to, crack, data structure algorithm problem at the top 4, or to top tech companies. We're going to do a linked list cycle. So I'm thinking it's this very similar problem, but we have to find at the intersection where the linked lists meet, the point where there's a cycle, the intersection point, right? So I'm thinking, okay, so we'll still have marker 1 and marker 2, and we'll have slow, pointing towards head, and fast, which is pointing towards head, right? And we'll loop through it. Well, fast and fast dot next, right? We'll move fast twice fast. Right, and we'll move slow, like one step at a time. So let's see. So let's do slow that next. So now, if fast equals slow, so now we know we found it's a cycle. So, right. So now what we're gonna do is we'll move fast towards the head, and and we'll move both items one step at a time until they meet. So while fast not equals slow, we'll move fast equal fast dot next, and slow equals slow dot next, right? Until, you know, illness return, you know, so let's step back for a second. So if we found it, we'll find the intersection point, so return the fast. If nothing is found, return, you know, none. I wish I could share the picture. So think about like there's 1, 2, 3, you know, and think about like 4 is where the cycle starts, and 5, 6, 7, 8, 9, and then goes back to 4. And, you know, think about like at this point, P and Q met, like the slow and fast, but we want to find at what's the starting point at the intersection. So once we found that, we'll move head to the, you know, the starting of the head, and we'll move K steps, and also at the same time Q will move K step. And eventually, once, you know, if, you know, that's what we try to do, and where they meet at the intersection where the cycle starts, we'll just return the value. If there's nothing is found, you know, we'll just return none. So let's try it. Okay, so it's accepted. That works fine.